Hey everyone, ready for a deep dive into AI? I mean, we're talking sentient robots, maybe even world domination, a future where chores are a thing of the past. Okay, maybe not quite, but seriously, AI is exploding right now and it's evolving faster than ever. Today we're dissecting some groundbreaking research from Andrew Scott and his team to, really give you the rundown on where AI is headed, like for real.
Yeah, it's exciting stuff.
For sure. We've got excerpts from their paper, The Future of Artificial Intelligence, published in the International Journal of Artificial Intelligence and Machine Learning just last year. They actually built a model, like a predictive model, that maps out the potential AI all the way to the year 2100.
Wild, right?
It's ambitious. I mean, 2100, that's a long way out. But the ideas they're grappling with, they're definitely reshaping our world right now. Absolutely. But before we fast forward to robot overlords, let's talk about where AI is right now. I mean, we're bombarded with all these sci-fi scenarios, but the truth is, most AI we interact with is, well, a lot more low-key.
It's true. Think of it this way. The AI we have now is like a star high school athlete, the kind who excels in one specific sport. They might be amazing at basketball, but ask them to play the violin or, I don't know, write a sonnet and they'd probably struggle. That's narrow AI, highly specialized, incredibly competent, but limited to specific tasks.
So basically, my Spotify recommendations are safe, but my coffee maker isn't about to start composing haikus anytime soon.
Exactly. Facial recognition software, spam filters, those eerily accurate shopping recommendations. That's your narrow AI in action. Impressive, yeah, but not exactly sentient. However, that doesn't mean things are staying static. Even though we're in the era of narrow AI, the sheer amount of money being poured into research and development is astronomical. We're talking tech giants, venture capitalists. Everyone's betting big on the future of AI and where it's headed next.
Okay, so big money, which means big developments on the horizon. Let's talk about where this is all going. What's next for AI?
So Scott's research breaks down AI's potential future into three distinct levels. We've already touched on narrow AI, but beyond that lies the realm of general AI, or AGI machines capable of human-level intelligence across the board. Think of it as that star athlete suddenly becoming a multi-talented virtuoso, excelling in any field you can imagine.
Okay, now we're talking. AGI sounds like a game changer, but it's still a ways off, right? What about beyond AGI? What's the final frontier, so to speak?
That would be superintelligence, which is, well, exactly what it sounds like, intelligence that surpasses human capabilities in every way imaginable. Now, it's crucial to remember that these are projections, not guarantees. Scott's model gives us a timeline based on various factors, but predicting the future, even with fancy algorithms, is never an exact science. There's a lot of debate about how quickly we'll reach AGI, let alone superintelligence.
So the big question is, when will we have to start prepping for our robot overlords? Just kidding. Mostly. But seriously, knowing that those different levels of AI are on the horizon definitely raises the stakes, right? So we've got these levels of AI, from narrow to superintelligence. But what's actually fueling all of this? Like, what are the building blocks that are going to take us there?
Yeah, great question. Scott's research, actually, it really hones in on 6 key areas within narrow AI where we're seeing the biggest breakthroughs happening right now. And these aren't just like incremental improvements. We're talking about the foundational stuff, the things that are going to pave the way for those giant leaps towards AGI and beyond, really.
Okay, let's break it down then. Hit me with number 1. What's first?
First up, we have computer vision. And this isn't just about like teaching a computer to recognize a cat in a photo, though that's impressive in itself. But we're talking about machines that can actually understand the context of an image, the relationships between objects, the nuances that we humans pick up on without even thinking about it.
So instead of just seeing a jumble of pixels, AI is starting to actually see the world more like we do.
Exactly. Imagine medical imaging, for instance. We're already seeing AI systems that can analyze scans, like CT scans, and detect diseases, even something like cancer, with an accuracy that rivals, even surpasses human doctors in some cases. They're even spotting crucial details that human eyes might miss. That's the power of computer vision.
Wow, that's really incredible. What's next on the list?
Next up is machine learning, which is, well, it's the real engine driving a lot of the AI that we interact with every day. It's where computers are learning from data without being explicitly programmed for every single scenario, And it's already changing the game in fields like fraud detection, where AI systems are spotting patterns, anomalies, things that would take humans like ages to uncover.
Yeah, it's like they can see through all the noise and just zero in on those needles in the haystack, right? But what makes this different from good old-fashioned algorithms, the ones we've had for years already?
The real game changer here is deep learning, which is actually a subfield of machine learning. It's based on artificial neural networks, these structures inspired by the human brain, and they're enabling AI to tackle incredibly complex tasks with mind-blowing accuracy, really. We're talking about things like being able to predict stock market fluctuations or personalizing medicine based on an individual's, genetic makeup, even composing original music, music that's practically indistinguishable from human-created tunes.
Okay, now that's just cool. Deep learning, it really seems like it's living up to its name. What's next on the AI hit list?
Third on the list is natural language processing, or NLP. You've probably interacted with NLP in your daily life more than you realize. Think Siri, Alexa, Google Translate, they all rely on NLP. But let's be real for a second. We've all had those moments where these tools completely miss the mark. True understanding of language, the nuances, the humor, the sarcasm, that's still a major hurdle.
Yeah, you're telling... I once asked my smart speaker for music to fuel my existential crisis, and it suggested like upbeat pop songs, all about sunshine and rainbows. Not exactly what I had in mind. So how do we get from these, sometimes clunky interactions to AI that truly gets what we're saying?
That's the million-dollar question in NLP research. For machines to truly interact with us on a human level, they need to go beyond just recognizing words and grammar. They need to grasp the underlying meaning, the intent, the emotions, everything we're conveying.
It's like they need to understand not just the dictionary definition of a word, but like all the baggage, all the subtext that comes with it. Okay, what's next? Give us something a little more tangible.
All right, how about robots? And before you ask, no, we're not talking about the Terminator, or at least not yet. Today's robots are still largely confined to factories doing, repetitive tasks, but it's the development of cobots, robots that are designed to work safely and collaboratively alongside humans that's really shaking things up.
Cobots. So like robots that can actually lend a hand instead of just, replacing one.
Precisely. Think of a cobot as a highly skilled assistant capable of handling dangerous or tedious tasks while you focus on the bigger picture. The real challenge in robotics is weaving all these different AI capabilities, computer vision, machine learning, natural language processing into a physical system, one that can actually perceive, adapt, and interact with like the real world. It's incredibly complex, but the potential is immense.
Yeah, it's like trying to build a brain and a body at the same time. Yeah. That's a tall order. What's next on the list?
Next up is something that's becoming, it's already increasingly woven into the fabric of our lives, and that's the Internet of Things, or IoT for short.
Yeah.
Imagine a world where everyday objects, everything from your refrigerator to your car to your thermostat, are all connected, communicating, and actually making decisions. We're talking about a level of efficiency, optimization, and personalization that was unimaginable just a few decades ago.
Okay, so picture this, right? I wake up in the morning and my coffee maker, it already has a fresh pot brewed because it knows my schedule. My fridge orders groceries, like before I even realize I'm out of milk. And my car drives itself to work while I'm, still trying to catch up on the news. Is that the kind of future we're talking about here?
You're getting the idea. And while all of that sounds, incredibly convenient, the IoT also raises some serious questions about data privacy, security, and the potential for misuse. I mean, after all, the more connected our world becomes, the more vulnerable we are to things like cyber attacks, data breaches, that sort of thing.
Yeah, that's a really important point. It's like any new technology, right? Amazing potential, but also new challenges and risks that we have to consider. All right, what's the last item on our list of AI building blocks?
Last but certainly not least, we have what's often considered the kind of the holy grail of AI research, reasoning, and decision making. This is really the key to unlocking AGI, but it's also the area where progress has been the slowest and most challenging. We need machines that can not only process information, but actually think for themselves, apply logic, understand cause and effect, and really make judgments based on often incomplete information.
So it's one thing to teach a machine to like play chess by crunching through millions of possible moves, right? Mm-hmm. But it's another thing entirely to teach it to strategize, to adapt to unexpected situations, to like think creatively. That's the real challenge, isn't it?
It is. Imagine a machine that can not only solve a complex equation, but it can also explain its reasoning, can learn from its mistakes and then come up with creative solutions to problems that it's never even encountered before. That's the level of sophistication that we're aiming for, and it's still, it's still a distant goal.
Okay, so we've covered a lot of ground.